In this video, we're going to uncover why the unit circle naturally reveals 30-degree angles, and we'll do that by building something simple, a hexagon. As I've mentioned in my previous videos, the unit circle isn't organized randomly. It's designed in a way that lets us read it more easily by using geometry. We already saw how placing a square inside the circle divides it into 4 equal 90-degree sectors. By bisecting those, we obtain the familiar 45-degree angles and the 45-45-90 triangle. And now we can take it a step further. The 30-degree and 60-degree angles don't come from thin air. They come from inscribing a regular hexagon inside the unit circle. And you might wonder, why not use a pentagon? Because doing so immediately introduces messy radicals that do not simplify nicely or visually. And why not a heptagon? Because its angles do not admit simple exact expressions using elementary radicals. But the hexagon is different. When we inscribe a hexagon in the unit circle, geometry, algebra, and symmetry all agree at once. Each side of the hexagon equals the length of the radius, and the circle divides itself naturally into 6 equal arcs. Since a full circle measures 360 degrees, dividing by 6 gives 60-degree angles, which we can mark within the first quadrant, and so on. We don't stop at 60 degrees though, because trigonometry relies on right triangles. Bisecting 60 degrees introduces a perpendicular. This creates a simple right triangle and gives us two 30-degree angles. This is how 30 degrees enters the unit circle. So, in completion, the square is tied to the coordinate axis and perpendicularity. Some other systems that also divide space into 4 directions are a clock with 12, 3, 6, and 9, or the cardinal directions north, east, south, and west. This structure gives rise to the right angles and the 45-45-90 triangle. The hexagon is responsible for the equal arc spacing, the circular symmetry, and operates independently of axis. Basically, we have 6 equal sides that allow for rotational symmetry and give rise to the 30-60-90 triangles. Having these shapes allows us to combine geometry and algebra to simplify trigonometry and later on calculus and physics.